Yesterday. Oh my. Okay, no. Right. So I think yesterday we got. Well, we still didn't get anywhere, but at least we realized that our bind requests were wrong. And it was wrong, and well, I guess it's wrong because yeah, writing is a slice as bytes, and I think slice does not have any guarantees of order. So a couple of things I'd like to, let me just put this back, should I? Yeah, so I would like to understand why, and also understand how the new IO interface works. Because I think I've been putting it off for a while. So this feels like a good opportunity to understand them better. Right, so let me put the old thing back. What was the old interface? Bind ID. And then I can get rid of that for now. And I think I'd also like to try something. Bind message, let's say. MS bytes. Instead of M, can I do bind ID? And then do a hex dump of bind message as well. I think I'd like to not print the interfaces. Sync debug print of that. I think that is callback ID. Callback event. Deleted ID. Yep, this return for now. Actually, the return's unnecessary. Okay, so that should just be the hex dump. Build one. Expected type slice of U8. Wayland Window 289. 289. Expected type slice of U8. How did I work around that problem before? Then that's it. Cast discards const qualifier. It's incorrect. Hang on. Might still have it. Debug here. Wayland client. Interface. That makes sense. Doesn't make any sense. That's exactly what I did before. Alright, let's just look at the error. Vector type slice of U8. Maybe just const cast. Const cast. Yeah, that's how. Okay. Callback event. Yeah, I'm just gonna close that. What is this called? Sync. I think I also want to separate. Where is bind? Debug.print. Why does it been printed twice? Oh, because I bind two different methods. Message. So the message header, which is, I think, object ID, opcode, and then message len. Is there a way to like format it differently? And this would be, hang on, what? So the header, yeah, that's the header, and then should be the name. Excuse me. Message, yeah, this is message len. Unless it's not printed as dump hex. standard writer. Okay, it just dumps the bytes. So that should be the object ID. Opcode. Let me just check. Is the opcode 0 both instance? Bind. New bind ID, version, interface. Oh yeah, because it is global. Yep. Both times the opcode is 0. And it should be registry ID. The object ID looks wrong as well. Oh no, it is 2. Okay, so that makes sense. Right. So that's in the right place. So is the opcode. I'm guessing message len. I can print that. Where did it go? Find. Ten. Actually, it might be useful to just print standard debug. What if I just print the whole struct? This should be the message. Okay, I think that's much better. So that's the object ID. That's the opcode. Message size is 36. I think you could do echo. Oh, no. There was a way. I can't remember. Hang on. And shell. Oh, you need 2 brackets. $36. Okay, that does make it. Do you need 2 brackets? Or there's only 1? Okay. There's some shell syntax that I can't remember. Anyway, the message size is right. Name is 1. That's clearly not the name. Excuse me. What if I just minus bytes? Jeez. This is bind message. So the second one. It's also like nowhere close. Version is 5, new ID is 3. Okay, why does it do that? Standard mem is bytes. Let's read a bit about that. As bytes. Let's look at the standard. Dot as bytes. Given a pointer to a single item, returns a slice of the underlying bytes, preserving pointer attributes. Why am I here? Let's have a look at, well, I think this here. Oh no, I think it's better to look here. As bytes. Preserving pointer attributes. Returns a slice of the underlying bytes. And it returns pointer cast, a line cast of pointer. And it's cast to this as bytes return type of pointer. Pointer is type info of p.pointer. Pointer size is 1. What is that? This data structure is used by the Zig language code generation and therefore must be kept in sync with the compiler implementation. What is this size? Can I get... Let me get rid of this. What is that? Oh, that's the message. Right, I'll keep the message face here. So it's type info the pointer is type info dot type info, say bind ID the pointer. And I don't know what type that is. Guess instead, can I just do ID the bind ID. Does that work? Yeah, that's what I thought. Oh no, sorry. What was I doing? ID dot bind ID. Right, because there's no method defined called pointer. Okay. This is a function. What is this statement doing? Pointer cast, line cast, or pointer? What does that do? Pointer can be pointed to a type, an optional pointer, or the slice of t, or the slice of a type. Changes the alignment of a pointer. The alignment is used to use is inferred based on the result type. Added pointer alignment safety check is added to the generated code to make sure the pointer is aligned as promised. What is returns the number of bytes that this type should be aligned to for the current target to match the C ABI. When the child type of a pointer has this alignment, the alignment can be omitted from the type. The question is, how come I can read a slice of bytes which probably written by some C code. No, it's which is written by some C code. I can't write back to it. Let me check. Parse event. Yeah, parse event. Message len. I mean, there's. Oh yeah, I think what's this bytes to. Oh no, but that's the len. I read the bytes as is, and they read to a string or a slice of constituent U8. Can I find out mem.as bytes of bind id dot interface? Interface bytes. Interface bytes. Oh fuck, I forgot about that. Winter. Reached unreachable code. Set pointer.size equal 1. So what is the pointer size of this? So it's type info of p, which is just a typed up pointer. Oh, actually, I just realized something. It should be pointer. Just print the pointer type. Access of union field pointer while field struct is active. Guess can I use bind ID? Don't think that's gonna work. Yep. Can I do a type of? It's capital T. Access of union field pointer while field struct is active. What does that mean? Access of union. I just Google this. What's the question? Fail to stringify at a type has no members. Well, I think he made the same mistake. It should be small p, unless he's defined a method. Field pointer, well, field struct is okay. Maybe they changed it, but it doesn't explain what that error means. Okay, let's put that aside to the list of questions. But then when I call, what do I send request? Pointer to request. Well, it's already a pointer. Under that sprites. Type of pointer. But if I do type of, then it won't work. Type of. Why did that work? And that doesn't work. I know it works. That is wild. Okay, anyway. The pointer is just... I don't understand what is printing. Type info, type of pointer. Oh, right, okay. That's the pointer. It's a struct. Alignment is 8. Dot child, Wayland client ID to bind ID. Let me print the message. That's the one I want to see. Alignment is 8. Address place is generic. Child is central pointer false. Size is 1. What does that mean? Zig point. Let me check the doc. Pointer alignment. Pointer alignment refers to the requirement that a pointer's address must be multiple of a certain value, typically related to the size of the data type it points to. Proper alignment is crucial for efficient memory access and to avoid potential errors or crashes in programs. Is it so that, what's it called? The in-size thing. Is it so the right amount of memory can be read, maybe? How memory addresses are organized for efficient access by the CPU. Proper alignment is crucial for performance and correctness in programming. What is pointer alignment? A pointer is considered aligned if its address is a multiple of a specific number. Okay. Typically, the size of data it points to. So in this case, the alignment is 8. That's so So that's eight bytes. It probably explains why. No, it still doesn't explain. Say if this was a packed struct, assume this didn't exist, and request is a packed struct and without an interface, what would be the alignment? 16. Hey Jack. Hmm. And what is, there's no other difference to the pointer except the alignment. Hey Jack, I'm just trying to understand pack structs and interfaces. Well, mainly the IO writer and reader. Because I want to find out like why this doesn't work. I'm trying to get bytes for a slice. Okay, and if I add this back, Zig won't like it. Okay, so pack structs cannot contain fields of type slice of U8. Hey, you pack it too. What? Funny name. Pack structs cannot contain fields of type slice of U8. Slices have no guaranteed in-memory representation. Okay, it makes sense because if I print, have I printed the, yes I have. No. Got rid of that, got rid of the packed, and then put the interface back. Yeah, because this makes no sense. Should be the interface name. The thing is, how is Zig able to read that as a string? Message. What is message again? No, it's the whole thing. I'll leave the pointer info. Can I get it for slice of const U8? Don't think that will work. Oh, it works. The alignment is 1. Interesting. I mean, it makes sense because it's a slice of U8. But let me, can I print both of them? Yeah, this will be the slice pointer. The request pointer. Any, and then slash n request pointer. What the fuck? How did the request pointer become one? Oh, because they're both the same thing. Type of M. Okay. Now it makes sense as to why the hex dump looks like that. Oh, and okay, I see why you can't do pack struct. Because let's say if this was a slice of U32. Okay. Because based on what type of slice it is, the alignment changes. So that's why you can't have it in a pack struct. Is that probably that could be the reason. I made this example for IO, writer usage. Alright, I'll check that out once I figure the pack struct. Okay, so I mean, that does make sense. If that is the reason why slices can't be in a pack struct. So we need something that can guarantee the alignment for a string. Okay, that was only line 1 of set pointer size. Pointer dot size is 1. Interesting. So what is pointer dot size? This data structure is used by the Zig language code generation and therefore must be kept in sync with the compiler implementation. Pointer size is size. Size is an enum. It doesn't, I mean, one, many. Okay, size should be 1. I mean, not sure why. And size is size of pointer dot child. Yeah, that makes sense because that's the underlying type. In the case of message, it's request and it's size of this. Okay. Copy pointer attributes. What does this do? Source is the pointer to the struct. Size and child is the original. Why is slice an array of bytes? Right, okay. Let me just check. Copy pointer attributes. Source, size, and child. Interesting. Native size of bytes. Oh, okay. Oh, that kind of makes sense. That's pretty cool. Because you only sort of need how many. You only need to know how many bytes to copy. Interesting. Type info of source dot pointer. Why do we need that? Oh no, that's the pointer. Okay. And it returns. What does this do? Never seen that before. Type. This function is the inverse of type info. It refuse. Must be a typo. Oh no. Re. Jeez. Okay, whatever. It does that. It does that thing. Okay, I think I don't know what that means. Type information into a type. It is available for the following types. Refees. Oh jeez. Gonna have to understand that then. Third person is singular simple present indicative form of refi. What is refi again? Something abstract as a concrete material thing. Basically construct the type based on parameter. Okay. I don't know how you understood that from. Okay, it puts back some type information into a type. It's available in the following types. That should be struct as well. Okay. So basically you can do anything. Contains undefined. Okay. So you construct a new type. Oh, okay, you pass it the original type. I think that's is it inferred from, yeah, okay. Oh, okay, I should have looked at the arguments. So you provided type info. What about the rest of the stuff? Pointer, size is size. So this is basically just filling up. You change anything here? No, I will, because it's just a copy. How do you get a slice of bytes from this? As bytes return type of pointer. What is dead beef? Native ending. Okay, because this is the U32. Back code phase is 0. Back struct ABCD. Mr. Haka. People have weird names today. Right, I'm getting distracted. Where was I? Okay. Okay, at least I understand why you can't have slices in packstruct. Get bytes slices Zig. Let's have a look at packed struct. Packstructs, like enum, are based on the concept of interpreting integers differently. All packstructs have backing integer, which is implicitly determined by the total bit count of fields, or explicitly specified. Packstructs have well-defined memory layout, exactly the same ABI as their backing integer. What is ABI? Application binary interface. An application binary interface is an interface exposed by software that is defined. Can I just check? That is defined for in-process machine code access, often exposing software. The exposing software is a library and the consumer is a program. An ABI is at a relatively low level of abstraction. Interface compatibility depends on target hardware and software built toolchain. In contrast, an application API defines access in source code, which is relatively high level, hardware independent, and human readable. Okay, whereas an API defines an interface to compiled code. Binary compatible. Okay, it's the same instruction. Okay. I think I kind of understand. So I'm guessing C has a certain way of aligning their bytes. So Complete ABI enables a program that supports an ABI to run without modification on multiple operating systems that provide the ABI. Must provide required libraries that implement the ABI, and there may be other prerequisites. Okay, I mean, I kind of get an idea. Go back to Pact. Pact union, Pact struct. Right. All Pact structs have a backing integer, which is implicitly defined by the total bit counts of fields or explicitly specified. How can you specify? Can you? You specify, I don't know how you do that. Pact structs have well-defined memory layout, exactly the same ABI as their backing integer. Ah, okay. I think like tagged unions. Interesting. Is that an example here? No. So, in the case of this below. All right, sorry. Fair enough. Oh, so that would be the size of the whole thing. So if I specified, but I still couldn't, yeah, because the alignment doesn't work. Okay, now. Each field of a pact struct is interpreted as a logical sequence of bits, arranged from least to most significant. Allowed field types: integer, bool, enum, pact union. Field uses exactly the bit width of its integer tag type. You can use pact unions. Field uses the bits of its backing integer. So you can also use a pact struct in a pact struct. This means that a pact struct can participate in bit cast and pointer cast to reinterpret memory. This even works at comp time. Okay. Spill some coffee. Okay, I think I understand pact structs and why you can't have slices within them. If I can... So does that mean I need to create the bytes myself? What are the options? If you want to... Oh, there's a bit more, actually. The backing integer can be inferred or explicitly provided. When inferred, it must be unsigned. Interesting. What is the backing integer? A backing integer which is implicitly defined. Okay, gotcha. Is this thing? when explicitly, okay, if it's inferred, it'll always be unsigned. When explicitly provided, its bit width will be enforced at compile time to exactly match the total width of the fields. Time to exactly match the total bit width of the fields. Okay. So this is 24, so I'm guessing there will be a padding added to the end. Oh no, if there'll be padding in between. Just I want to see what that would look like. Let's try the same example. Const s is fact struct u32 is u16 and b is u8. Const as bytes is standard dot as bytes to s dot a equals 8 dot b equals 8. You can't do that, can you? Maybe not. Debug dot what's it called? Dumpx. Bytes. Lacking integer type as u32 has a bit size of 32, but the struct fields have. Okay. Yeah, that makes sense. Oh, right. Okay. I should have just read the line below. But okay, at least I know. So you have to like sort of guarantee. So where did it go? 16. So that should compile. Okay, that makes sense. Right. Okay. Don't think I need these. So it's kind of like a compile time check. Interesting. Zig allows the address to be taken of a non-byte aligned field. Zig allows the address to be taken of a non-aligned byte field. Bit field pack struct u3, u3, u2. Const pointer equals pointer to b. Okay. But I don't understand. Allows the address to be taken of a non-byte aligned field. This point, and you can get the value of b. But I mean, it makes sense, but I don't understand why it's explicitly. Oh, that maybe there's something else. However, the pointer to a non-byte aligned field has special properties and cannot be passed when normal pointer is expected. I should just carry on read it. So let's look at the same example. same pack struct, same values, pointer to non-byte aligned field. Expect, what is bar? Expects a const pointer to U3. Ah, interesting. Is it only for pack structs or? Interesting, because the type info now has alignment info with it. 131. What is that alignment? 1:3:1. Pointer host size 1 cannot cast into pointer host size 0. Pointer bit offset 3 cannot cast into pointer bit offset 0. Okay. This is the pointer host, pointer bit. Don't know what that is. Okay, the 3 makes sense. Does it? No, it doesn't. Oh, geez. The minimal unit of addressing is a byte. So taking a pointer from the middle of a byte is not normal. Ah, I see. But why does this work? The pointer to a non-byte aligned field has special properties and cannot be passed when a normal pointer. Okay. So it's no longer a regular pointer. So you can't pass it as such. Because it needs, I'm guessing, this info. Right, okay, I understand. In this case, the function bar cannot be called because the pointer to the non-ABI aligned field mentions the bit offset. The bar cannot be called because the pointer to the non-ABI aligned field, which is X, mentions the bit offset. Mentions the bit offset. But the function expects an ABI aligned pointer. Or is it the other way around? Pointers to non-ABI aligned fields share the same address as the other fields. Interesting. Okay, I'd like to print this out. Let's copy that and get this here. Standard debug print any and any. Bit field.a. I guess 2 would have been enough. Field.b. Bit field.c. Interesting. Yes, they do share. Oh, okay. I get it. Cause they're somehow part of the same. That is wild. How does it work? Interesting. Because it's just, I'm guessing it's just the start of the pointer, and from there you read this amount of. So you can read U3 from here, and then I guess U3 plus U3 from here, the same pointer. Then you add these two, and you can read the last one. Maybe. That is quite interesting. I like that. Okay, that makes sense. Pointers to non-ABI aligned fields. Why are they non-ABI aligned? I thought the whole point of packing a struct was to have them ABI aligned. Isn't that what it said here? Pack structs have well-defined memory layout, exactly the same ABI as their backing integer. Ah, okay. And that's why you can't access the pointer. This is quite interesting. I had no idea. Okay. This can be observed with bit offset off and offset off. Zero 3 6. And I think that was passed here. Interesting. What is offset off? They're all 0. Can I check offset off? I think it's offset. It turns the byte offset of a field relative to its containing. How can they all be 0? It turns the byte offset of a field relative to its containing struct. Byte offset. Ah, okay. Byte offset. Yeah. They all started the same. Yeah. Like just as you can see here. Okay. And bit offset wouldn't be because, well, they can't all take the same address. Returns the bit offset of a field relative to its containing struct. For non-pack structs, this will always be divisible by 8 based on their alignment. For pack structs, non-byte aligned fields will share a byte of. Interesting. Okay, that's why. Now I get why you would use a pack struct. Because if you didn't, like a U32 or like a U3 or whatever, would always take a minimum of 8 bits. Okay, now I get why it's called a packed struct. It's packed. I mean, sounds obvious, but I think okay. Pack structs have the same alignment as their backing integer. However, over aligned pointers to Over-align pointers to pack structs can override this. Not sure what that means. Align S is, oh, you can specify the alignment. What is that inferred? Pointer is, yep. Pointer to B. So pointer to U32 is pointer to B. Oh, you can change it. No. Well, okay, actually the types are different. So U32. Yep, that's an alignment of 4 because they're both U32, I'm guessing. Pointer is pointer to something aligned 4. Pointer to B is a pointer to B. Not sure I follow this. Is this a new pointer? Okay, let's try this one out. Where did it go? Yeah. I think I don't need this, don't need that. Yeah. S is that, and then we can get const. S is, was it a pointer? No, it's just a struct. Equals the equals 1. B equals 2. What if I didn't specify this? Would still be S. So align is a keyword. Let me try without it first. And then pointer. Is this pointer to S? What if I had, it seems to be the same. S has an alignment of 8. So it's the same as specifying, it's called U64. Will that compile? Let me just check that. Okay, so what if I just, right, okay. Align 4, well, what does align 4 mean again? But S wouldn't have an alignment of 8, would it? Because it's a pack struct. A U32 has an alignment of 4. So I think this would be implied, right? Okay, let me just check. I think I can check the pointer info. Standard debug, except all fields are packed into a U64. Standard debug, print, I think type info of type of S thing and dot pointer. Oops. This should be any. I think it should be type info dot pointer extra bracket. I think I can just do S. Oh, sorry. And there should be pointer. Alignment, yeah, actually, you're right. The alignment is 8. Because it's the alignment of the whole. What if there was no B? What would be the alignment? It's 4. Oh no, I'm looking at the wrong one. Jeez. S. Okay, alignment is 4. Also, it becomes the alignment of the whole struct. Interesting. Okay, okay, I get that. So you are forcing it to be an alignment of 4. So if you didn't have this alignment of 4, you wouldn't be able to grab this. Is that what they're trying to say? Pack structs have the same alignment as their backing integer. However, overaligned pointers to pack structs can override this. I would like to see, let's say, wondering why have you chosen Zig? Why did I choose Zig? I mean, I just, I don't know, really. It looks similar to Go, and I wanted to get better at a low level language. And Zig seemed like interesting. And I mean, it's okay. There's a bit of suffering, true. But I think it's also, the suffering is also because I am impatient, right? I expect things, I just expect to know things. I think which is the cause of most problems. Line 4. So I forced it to be an alignment of 4. So const pointer or P would be S line 4, or do we even need this? Okay. Equal to pointer to s. Did I miss the type? Oh, so use like it's like a cast. Interesting. Okay, now I see what they're trying to say. You can force the alignment, like you can override the alignment. And then now this would work because U32 has the same alignment as this cast alignment. Okay, I see why. So if I just comment this, copy this, and comment these out, and I removed that and this, and I tried to do const U32 is pointer to U32 equals, right? Yeah, equals p dot b. Can I just do print? It's like it can be any. U32p. So the compiler would complain that the alignment is not the same. Oh no, that's a different problem. This should be pointer to s. What's that again? Expected type. Why is it expecting? Oh yeah, okay. Const. P. The B. Hang on. The point. It's already a pointer. Okay. So this should not work if I'm right. But seems to work. So what was the point? Well, that makes less sense. So what would be the difference if I did this? SA. Is equal to underscore a dot b. Score 32 underscore p underscore a. What's that again? Type. Expected that type. Found const. I can cast that. Guess this would complain as well. It's not. I mean, they both seem to work. What if instead here I did that. Go to do that. Made this S. What would that do? Yeah, you get the same pointer. So I don't understand the point of this. Maybe any I do, hang on, type info, type of pointer to dot pointer. Type info, type of dot pointer. I missed a bracket somewhere. Oh, here. I should put a new line. Can't read that. The both in sconce is volatile. The alignment is the same. So I don't understand. Oh, because they both point us to U32. Hang on. So what if I wanted to print pointer to P and then here P underscore A. I don't need that. I mean, they still have the same alignment. So it really doesn't change anything. I don't know. I don't understand the point of this. It's also possible to set alignment of struct fields. Interesting. I mean, why would you need to do that? Not sure. Equating packed structs results in comparison of the backing integer and only works for the equal and not equal operators. Equating packed structs results in comparison of the backing integer. You mean for this one? Yeah, could be. I mean, you would just use a U2 there, right? And a U64 here instead. Maybe, I don't know. Yeah, this one I think you'd have to know. Comparison of the backing integer and only works for the equal and not equal operator. Expect x equal y. Interesting. Oh yeah, because the alignment is guaranteed. Is that why? Because it's a fact struct. So the order wouldn't matter, is my guess. Yeah. Yeah, that makes sense. Field access and assignment can be understood as shorthand for bit shifts on the backing integer. These operations are not atomic. So beware using field access syntax when combined with memory mapped input output. Instead of field access on volatile pointers, construct fully formed new value first, then write the value to the volatile pointer. It works because it's just a number you can compare struct normally. You mean they have the same values? It's just a number, so you can't compare struct normally. Equating results in the comparison of the backing integer. I wonder what's the backing integer. Like, are these the backing integers? Well, anyway, I mean, this still kind of makes sense. But you normally can't compare structs. Ah, okay, I see what you mean. Yes. And I'm guessing this is also some compiler magic in that case. Like this comparison. This is GPI register, pack struct U8. 1, 2, 3, 4. Result is pointer from int. Yep. Write to GPIO. Example of what not to do. It's bad. Instead do this. Oh, you changed the whole. Okay. So you should. And why is that again? An assignment can be understood as shorthand for bit shifts on the backing integer. These operations are not atomic, so beware. Using field access syntax when combined with memory mapped input output. Memory mapped input output. Instead of field access on volatile pointers, construct a fully formed new value first and write the value to the volatile pointer. Okay. Okay. Right. But I still don't know how to write a. So that means I have to convert this interface into some form of a number and then pack it in struct. Or I can't use a pack struct. What are the other options? But at least I have like quite a few answers, quite a few questions answered. What are these? Don't need that. So it makes sense why up to the header is in the right place, but everything else is no, because it's trying to align. Where's my mouse? I lost my mouse. Well, anyway. Oh, the battery died. That's not good, is it? Right, okay. See how far we can go without the mouse. Okay, so I do understand why this doesn't work. And you can can see that the slice pointer can I go up? Yeah. Here. The alignment is not the same. What is the slice pointer? Right, but that was just an example. And if this was a U8, I think this would be an alignment of 1. Oops. And which is not the same as the request pointer. Okay, now I know why it wouldn't work. Now the question is how to make it work. Well, I didn't even get to the I/O interface. Let's get rid of these. Yeah. Don't need that. Interface bytes. What are these? Oh yeah, okay. I think that's not a bad idea. Standard mem.s byte. What did I want? I think it's pointed to find id.interface. Interesting. Even if you get the bytes of the interface, it doesn't make any sense. Why is that? And id.interface. Can I do that? Yeah, they look so different. Oh. Does that mean I don't know if this is gonna work, but okay, so now I get why, Jack. You said you can use the writer. I just realized I can't stop the stream without my mouse. So I guess I'm streaming. I don't know where the cable is for the mouse charger. Right, okay, so I mean, I do have to work, you know. So would that mean the other way to do it is, like you mentioned, using a writer and then just writing individually bytes? Okay, so I mean, I guess since we can't use a backstruct, That seems like the other way to do it. I mean, I meant like I can write the header as is because the head is fine. And then in that case, oh, it's already a pack struct, right? So I would just get rid of this request type. And let's have a buff. Var buff is, let's say, 128, like you mentioned. Should be more than enough, yeah. Defined. Const writer is standard.io dot. Is it writer? Or is. Okay, it is capital. Doesn't need a buffer. Standard. Okay. Oh yeah, I think you mentioned yesterday. Writer. Hey, you can get pretty far without the mouse. Oh no, can't use. Okay, this is a problem. There's a page up. Oh yeah, there we go. Oh, I see, fixed. Writes to a buffer and returns an error. Writer dot fixed. So that returns a writer. So I don't need that. Dot fixed. Where is it defined? Writer dot fixed. Guess buff. So writer dot. Is it called write or flush? No. Page up. Writable slice greedy. Default flush. Writer, comp time. Is it print? No. Print address, print ASCII, format, flush, fixed rain. Oh, writes to buffer and returns error. Writer failed when it's null. Send file, rebase, print factor. I know I'm not finding that link. I have to use like page up and down. Can I use write struct? Yeah. Let's try. Writer dot write. Hang on. If I can use write struct w and then value is a message, and the ending is dot big. Is it big? Post. I can check that. Built-in dot ending. I used the endian somewhere else. Endian. There, host. I think it was socket. Yeah. I just little, but where did I use it again? Host. And I can't remember. Was it here? Connect. Anyway. Built-in, standard built-in .zig. Do I need to import? I do have it. There's import built in. Is it built in dot endian dot little? No, it's not. There endian. Standard built-in endian. Okay. I guess, can I not just use little this way? Or is it little? This is writer. I mean, it doesn't seem to complain. Guess don't need that. Question is, will this work? Even with... I think it should. Okay, let's get rid of that. Temp hex writer dot buffer. Okay, and then yeah, don't send. Maybe send find data writer dot buffered. Find data. Can this be a const? And don't need that. Okay, I'll just print the rest. Find data. Right, member function expects 2 arguments, found 3. I thought it was 3. Oh, this. Oh, because. Oh, sorry. I always forget. Already passing the writer. And I think this can fail. Try. Expected type. Okay. Right. Ill-defined memory layout. What does that mean? Oh, okay. It doesn't like slice. Okay, so that means I'd have to write here value is m dot header, m dot name. Oh no, this is not a struct. Right. Right number. What will be oops. Right splat, right slice swap. Slice endings, blurs. Right int. Okay, I see it. Be an int. What does it need? Type and type value and endianness. Okay. Let's type first. M dot name can be type of m dot name. Is it type of capital T? And then I forgot to write the len. Name to len. Okay, and I need to write slice, right? Slice. Writer type slice and ending. Right slice ending, right slice swap. I mean, the ending one looks correct. Right all. I mean, oh, there is actually a right method. Okay, right all takes writer and bytes. The m dot. Oh, I suppose. Why do I even need this? All right. M dot, not M dot, bind ID dot interface. We'll get rid of that later once it works. And then I can write int name to version. Oh yeah, the length of the interface. I think it's because I included it in the interface. Did I? No, it's a constituate. Where's len? Here. Let me just check what did I put the value. Bind. New bind ID. Okay, len is interface.len, so at least it's the right thing. Let me check the order again. Right struct is the header. Name. Wayland app. How do I get to bind? I mean, I do miss the mouse. Oh, I can just go down. Page down. Delete. Where is bind? Registry. There. It's name and then ID. Okay. It's the name. There's also a name. Don't need that. Length. Then the interface. Why is there another? Okay, I need to rename this. Version. And then new. It includes the null byte, the interface. Is my guess. I mean, it's just a guess. I'm not sure, really. Version, but I think it does, because when I do the comparison, we do add the null at the end. Interface, version, and then finally. Don't need this. This should be right int. Oops. Version to new ID. Okay. My data is right at a buffered. Alright, let's see what that looks like. I mean, it's looking better, but it doesn't look right still. Let me check the message. So it's object ID 2, that's, yeah, correct. And then opcode is 0 because it's bind. Message length is 36, which is the length of the interface I checked before. And then what was after? And then name. Name is it 1? I think it might be, but I'm not sure. I guess I could just print that. Where is the interface? Yeah. It's not. It, yeah, you are right. So I need to round up the length. No, but I think, shouldn't it be padded when I get the message? Let me check. Global, pass global event. Maybe I can include interface len. No, I think it is. Because oh, sorry, keep the whole thing. And I think the interface length does include the padded bits. I can print actually the original interface. Standard debug dot print. Oh, but this might be too many. Can I just print one? I think here. Let's print it. Yeah. Standard debug print. Any. But it might print it as string interface. To be fair, it looks totally different. Ah, because what is the length of that interface? Yeah, that's not right. Because it should be 16. Ah, I know why. Because I think here, do I round up? Bytes to value. Here, in size. Okay. So that means I need to do the opposite of this. Oh no, I don't. Here. Dot interface. Can I just add it here? Const padding is in size. I think it takes type. What did I call it? I think this can be outside. Type and bytes. So I need U32. Find id dot interface dot len. And then find id dot interface. I can't extend a slice, can I? Let's create interface buff is okay. I can just say I can add. Okay. Interface buff. This will be find id dot interface dot bind interface plus Len. Oh well, padding includes. Oh no, this can just be padding. I mean, it doesn't look right. Under debug dot print interface buff. It's. I mean, I don't know if it's right. I mean, that's fine. I can fix that. Splat byte. I did see that. I think I gotta fix the padding. This is just bind id dot len. Yep, because that is the interface dot len. Writer dot splato. How can I switch tabs? Here. Splat all. But that takes a slice of constituate. Okay, splat byte all. Looking at the wrong one. Byte all. Ah, interesting. Right. So I just add null to the difference. Interface, and this would be try writer dot. What was it again? Splat. That's splat. Byte all. Takes writer. Byte is null. Then takes n, which would be find id. Oh, and find id dot adding minus. And I just do interface dot id dot len. Where's the splat gone? I lost the splat. Now comma padding. Okay. What am I missing? Splat byte. Splay byte. Oh. Okay, I do see the padding now. I guess. Does that mean padding? No, padding. What's the word? That would mean the message is now right. Good point. Let me check. Find. How do we? Oh yeah. I think if I set these. Something should happen. Well, I guess I do still need to set the buffer. Oh yeah, I forgot to sync. Try. Was it sync? Socket new ID. ID dot new ID. Is that what it's called? Yeah. It does return. Where did that event go? Callback. I think this would be standard debug. Print. Callback. Events. I think that's what the first thing does. Yep. And then if I call sync, you said maybe I can call it here. Would it make a difference? Well, maybe, I think maybe I'm not handling something. How do I know if it's like something went wrong or not? Maybe I try sync here. I think, where's bind? Let me get rid of some of these print statements. Needed. The interface, don't need that. Oh, okay, just leave it as is. Callback event, but I don't know if I can. Is there a way to know? Where's the book? Okay. I mean, I know, at least we know the bind message is right. I'm not sure if anything else is happening. Or like if I'm doing something else wrong. But I would have to do that tomorrow. I'm quite late. All right, how do I end the stream? Maybe I can use this other mouse. Let's see if this works. Okay, mouse is back. All right. I just want to check the documentation just quickly. Find. What was I trying to do again? Commit surface. Commit surface. Regions is double photo to modify the pending state opposed to active state used by the compositor. Okay. I think what's it called? I'm not sure if I'm supposed to get events back. XTG. This is ping event, which I don't seem to get. So I don't know. I think something still might be wrong. Anyway, but I'm a bit late. Quite late actually. That's okay. I think I'm gonna have to call it a day there. Jack, as always, thanks a lot for your help. At least I have a better understanding of packed structs and how to use the writer interface a little bit, nothing concrete. I mean, it'll take a few more days, but I'm sure we'll figure this out. Right, okay. Hope you have a good one, and I shall see you back here. What's tomorrow? Friday. Yeah, see you back here tomorrow. Hopefully by the end of the week, at least. I get a window going. Yeah, yeah. We've got till Sunday. I mean, there's no time limit really. Right, okay. But also I think I'm not in a hurry because if I need to understand something else, that's kind of the point why I stream, is to get better at Zig and programming. So I think time really is relevant. If it takes too long, it's fine. It's just not very entertaining, that's all, which is fine by me. Alright, I think that's it. Hope you have a good one, and I'll see you back later. Bye.